So hello, I'm Martin. We're going to see today the consumption of the Wemos D1 Mini. Wemos D1 is the ESP8266 Wi-Fi chip, and we were trying to get lower the milliampere. That's what we are going to check today. It's a mini Wi-Fi board with 4 mega flash based on the chip ESP8266. That we can see here has 11 digital input-output pins. All have PWM, E2C, and has only one another input. You can see there is A0, and well, what we're going to track today is just to see how much it consumes. It's a Wi-Fi chips, so it consumes quite much more than Arduino. And that's what we're going to do. We're going to see if we can just make it consume a bit less. Right now, the battery circuit is like this. The battery is connected to ground, and now is giving the alimentation to the 5 volts here. We're going to measure that, and then we're going to go to the 3 with the diode here. We'll try to see what's the difference in consumption, and we're going to report it. We are just using a very simple sketch that connects to Wi-Fi and does some really simple functions like turn on and off this relay here, and also sends a message to the digital LCD here. Nothing else. It's a very simple sketch. I'm going to upload it later to the blog fasani.de. So let's start with it. Let's connect the voltmeter here. So now it should be restarting. Reset it. Yes, restarting. It's going to take an IP address now, some seconds. So it's 73 milliampere, more or less. So now we put this IP address in the mobile, and we're going to see the Wi-Fi interface. Let's go there. 190, yeah, 033. Okay, let's do it here on my mobile device. Yes, so this is the Wi-Fi interface. Wi-Fi interface is what the chip delivers through HTTP. So now let's check. Let's put the relay on. Relay consumes like 50 milliamperes, and now it's 126. It was 75 with Wi-Fi on, only hearing, with the server hearing. Now it's 126 with the relay on. Let's put it off. Now it's going to be like before, 75. Very good. Backlight doesn't affect too much. It's PWM. Backlight on, high, off. Yeah, it's just 2 milliampere more. It's not a big deal. And now there is 2 things more. We will put it in deep sleep mode. See, deep sleep mode should consume much less. Now the consumption went down to 2.5 milliamperes. So now let's try to give the power to the 3.3 volts and see what happens. See if it changes. Okay, so now we took out the connection from the 4 volts, 4.2 with the battery full charge to the 5 pin in the Wemos. And we changed this to go directly to the 3V3 through diode. It will just take total charge is 4.2, will take half a volt, so it will be 3.7. Still 1 more than the specs. The specs say that the maximum should be 3.6, but it's just a minimal difference. Let's see if it works. Let's put it back here. Let's connect back the voltmeter to see how much it consumes. Alright, so now it should be restarting this guy. Yes, it's restarting. It's trying to connect, get the IP address, same as before. And let's see how much it consumes. Actually, only if it consumes the same as before. It didn't make a big deal. It just consumes exactly the same as before. So changing this through the diode didn't make a real difference. Now let's check the relay thing on. Alright, it consumes about 4 milliamperes less. It's not a big deal also. Off. Consume the same, 75, 74 is less than 1 milliampere difference, so it actually doesn't make any difference to change it. There is one serious advantage in this, in my point of view, is that you cannot have the 5 volts here with the battery power and connect the USB at the same time, because I did that already, and then this little diode that is here burns, gets out black smoke. You don't know how to do that. These two circuits, these 5 volts with the power regulator here that delivers 3.3 here, are isolated. So actually I think I will try it tomorrow, but I think that it won't burn it to have these two things at the same time, to have the USB and to have the 3.3 input. That would be the only serious advantage to doing this setup, but actually it's consuming a bit less. Nevertheless, if you're going to go with small batteries like these ones here, maybe it's worth the chance to consume even 1-2 milliamperes less per hour. So consider it fitting your Wemos or your ESP8266 by 3 volt 3 pin. Maybe it's a good idea. By the way, this is all what this silly program can do for now.